Hi, and welcome to this lightning lecture on handling orientation in Xamarin.Forms. My name is Kim, and if you ever want to get in contact with me, please feel free to shoot me an email at kim.phillpotts@xamarin.com or reach out to me via Twitter. So one of the questions that comes up quite regularly in regards to Xamarin.Forms is how you can handle device orientation and how to dynamically adjust your application's content to work well in both portrait and landscape. And even though this takes a little bit of additional effort from our developer's perspective, being able to cleverly take advantage of the available screen real estate is a great opportunity to make your application really shine. However, designing for device orientation brings various challenges and requires some pretty careful thinking. So in this lightning lecture, I'm going to cover off three main things. First, in order to handle rotation, you'll need to be able to detect the current orientation and be notified when the user has rotated the device. Secondly, we'll look at a few common techniques for reconfiguring your UI based on orientation. And lastly, there's some applications where it really doesn't make sense to have your application support multiple orientations. So we'll look at how we can lock your application to a particular orientation on each of the different platforms. So let's start off with how we can detect orientation in Xamarin.Forms and how we can be notified when the orientation changes. There's actually a number of ways we can detect orientation changes in Xamarin.Forms. We're going to have a look at a couple of methods. The first one is purely in our shared Xamarin.Forms code by using the inbuilt onSizeAllocated override. And then we'll have a look at a second technique where we rely on a platform implementation to notify our Xamarin.Forms application of orientation changes. So out of the box, there is no orientation property or orientation changed events in Xamarin.Forms. But what we can do is we can override the onSizeAllocated method on a page. This is going to be called when the page has been assigned a size, but also it'll be called whenever there's a change in page size due to rotation. This method is passed a width and a height. So to determine our orientation, all we really need to do is compare the width and the height. If the width is greater than the height, then we're in landscape. Otherwise, we're in portrait. So based on this information, we can then respond appropriately to the orientation. We'll talk about how you can customize your layout shortly, but first, let's jump over and have a look at this technique in action. So let's start off creating a new Xamarin.Forms project. And we'll just call this simple orientation. And go ahead and create that. And now we'll go and add in a new page called orientation page. So add a new file in here. We'll just call this orientation page. And now let's refactor our application to go and use that new page. So we'll come over here into Okay, so now let's add some code into our orientation page. And on this page, we're just going to have a simple label which is going to display our orientation. So let's go ahead and create a variable for our label. And then let's add that content into our page. We'll go and set its vertical and horizontal options. Just to center it. And add it in as our content. And we'll get rid of this here. Now let's override our onSizeAllocated method on our page so that we can get the width and the height of our page. So you can see this method is past the width and the height. So what we can do is we can just go and compare these values to actually derive our orientation. So let's go and run that now and see if it works. So first of all, we'll run it on iOS. Okay, and we can see we get portrait, and if we rotate the simulator, which we can do through our hardware, and we can rotate it, we can see that we get landscape. And if we rotate it right again, we'll see we get back to portrait. Fantastic. And we'll just test this works on Android as well. Okay, so we can see it's in portrait mode, and if we rotate it, we can see we get landscape there as well. Okay, so that all seems to work pretty well, but there's actually some other considerations we have as well. So first of all, our onSize allocated can actually be called multiple times during the layout cycle. And so we'll want to put a little check in there to only update when the page size actually changes. So let's add a couple of variables in here to hold our old width and our old height. And now let's put in a check here. Great, so now we only update our label when the page size actually changes. The other consideration is you might not want to have this onSize allocated code on each of your pages. So you might want to do something like push this down into a base orientation page or something like that to handle it for us. So let's go ahead and create a new base page. So we'll add a new page in here. We'll just call this base orientation page, for example. Okay, now in our base page, we'll want to create something like a orientation value enum to indicate the orientation. So let's go ahead and add that in. So now let's go and copy across that code from our onSize allocated from our orientation page onto our base orientation page. And we can probably get rid of this constructor here as well. So now instead of setting the label in this code, what we're going to do is we're going to create a way of notifying our pages when the orientation's actually changed. So we could do this in a number of ways. Obviously we could use events, but what we'll do here is we'll add a virtual method called orientation change that derived pages can actually go and override and be notified. So let's go ahead and add that in here. Now let's go and refactor our onSize allocated to actually go and call this method here. So now to finish this off, we want to go and change our orientation page to actually go and use this new method. First, let's change this from a content page to be a base orientation page. Now we'll go and override that orientation change method on the base. So in this method here, we're going to be past the orientation. Now we can use that to go and update our label if we like. And of course, now we can go and remove that on size allocated in this page because it's actually being handled by our base. So let's go ahead and do that. All right, so that's a little bit tidier. Now let's go and run this and just check that it's still working. Okay, we've got our landscape view and we've got our portrait view here as well. And we'll just test it on iOS as well. We're in portrait, we switch to landscape, and there we go. So you can see it's actually quite easy to detect our orientation just by using the built-in Xamarin.Forms features. But let's go back to the slides now and quickly talk about another option that we have here. Another common approach to detect orientation changes is to have some code at the platform level notify your Xamarin.Forms shared project, most likely through the messaging center or through the Xamarin.Forms dependency service. You can write this yourself, or there's actually a Xamarin.Forms plugin that's already available as a NuGet package which you can use to go and do all the work for you. The source code for that's available on GitHub, so you can always pull it apart and have a look at how it's implemented. But basically it bubbles orientation changes from the platform-specific projects via the messaging center, so you can actually be notified of orientation changes in your shared code. You can also use the dependency service if you want to call down to the platform to find out the current orientation at any time. Let's go and have a look at how we'd integrate this plugin into a project. Here I am over in Xamarin.Forms, and I've just got a simple Xamarin.Forms project. Just like the last one, I've just got a label that's the main content of the page. What we'll do now is we'll go and add that device orientation plugin. But there's actually a couple of things we need to do to make this happen. So let's go and have a look at the project page and see what we need to do. First, we need to get the component out of NuGet, and we want to install that into our PCL project and our client projects. Let's do that. Right click on packages, say add packages, and we'll type in Xamarin.Forms orientation. Okay, here's our plugin down here. Select that, click add package. Now we'll go do the same thing for Android and for iOS. There's also some initialization calls we need to include into each of the platform-specific projects. Let's have a look at those. So in our iOS and Android and our Windows Phone projects, we want to call device orientation implementation.init on our platform-specific code. So let's go and copy that across and put it into our project. In our iOS, we'll put that in our app delegate just after we call the init function. And we'll need to resolve that. And in our Android, we'll put that in our main activity. And again, we'll resolve that. For Android, we've got to add a little bit of extra code as well. So let's go back and have a look here. In Android, we need to provide this override for on configuration changed. Okay, on Windows Phone, you'd need to do something similar as well. Let's go put that code in here. On iOS, we don't have to do anything like that. That's it for the platform-specific setup. Now we want to go and subscribe to the notification messages in our Xamarin.Forms page. If we go back and have a look at the web page, we can see the code that we need to do here. So in our on-appearing override, we want to subscribe to the messaging center message. So we'll just go and copy that. On our page over here, we'll override on appearing. And in here, we'll place that code in there. Resolve that. And then we'll call a method here called something like reconfigure UI. And we'll pass the message through. Okay, we haven't implemented that method yet, so we'll right click on that and we'll create that method. And inside here, all we need to do is set our orientation label text with the passed in orientation information. The last thing we need to do is we need to remember to unregister from the messaging center in our on disappearing override. Again, we can copy that code from the website. There's also one additional thing that we need to do. Whilst we've registered for change notifications, we don't actually get the orientation when the page first loads. So what we're going to do is we want to actually call through to the dependency service on our page constructor to set our initial orientation. So we'll call to the dependency service and we'll get our implementation of iDevice orientation. We'll check if it's not null. It's good to do that. And then we'll call out reconfigure UI. And we'll pass it the result of our get orientation method. So let's go and run this application now and check that we can detect orientation changes via the plugin. We'll start with iOS. Okay, we can see we're in portrait mode. If we rotate that, we're in landscape. Great. Let's test it on Android. You can see we're in portrait mode here. We rotate and we're in landscape. Fantastic. Seems to work. We've now had a look at two different ways of detecting orientation. First, we looked at purely through Xamarin.Forms code using our onSize allocated override, and now using a plugin to provide notifications from the platform-specific projects. Now that we know how to detect our orientation, we're in a good position to have a look at some of the techniques that we need to use to configure our UI to work best on each of those orientations. Now that you know how to detect orientation changes, let's look at some techniques you can use to customize your layouts to take advantage of the orientation. There's obviously many different ways you can change your layout based on the device rotation, but mostly they just boil down to 3 common patterns. And just a note here, these aren't the official titles or patterns, these are just names commonly used to describe the methods. First, we have fluid layouts, which is where you basically just stretch your existing content to fit the screen real estate. Secondly, we have extended layouts, which is where you might want to use the same basic structure in either orientation, but maybe you just want to show a little bit more information or a little bit more functionality if the screen allows for it. And thirdly, you might want to switch between completely different layouts between portrait and landscape modes to take advantage of the real estate. Xamarin.Forms actually has a very powerful layout system, and most of the layouts will dynamically work with different size pages right out of the box. So that makes creating fluid layouts pretty easy, and most of the time you actually don't have to do anything special or do any special coding to deal with this. In order to control the sizing of views, you can use the vertical and horizontal layout options that are on the Xamarin.Forms view class. And just about every control derives from the view class, so pretty much all of your UI elements will have these properties. If you want something to resize to the actual screen size, you'll basically choose one of the layout options that is set to expandable, like center and expand, or start and expand, end and expand, or fill and expand. You'll actually find that grids are a pretty great option as well for creating fluid layouts. With these, you can set your row definition or column definition to a star width or height to occupy the full space. The next sort of layout we have is extended layouts. And the idea here is that you want to provide additional views or functionality when in landscape mode or when the space allows. And a classic example of this is the default iOS calculator. With that, when you're in portrait mode, it shows a basic calculator, but when you rotate to landscape, it adds some extra buttons to provide additional calculator functions, which basically makes it a scientific calculator. Now, the way you'll normally do this is by toggling the visibility of certain views based on your orientation. The third layout is the complementary layout. This is where you might want to display an entirely different layout for portrait and for landscape. And you can see an example of this in the inbuilt calendar application. When you're in portrait mode, it displays just a day's worth of calendar, but when you rotate to landscape, it displays a whole week view. You can achieve this by having different content views for portrait and landscape, and then just basically swapping them out as appropriate. However, an important consideration with this strategy is that you don't want to provide core functionality in your rotated views. You have to remember that users may never actually rotate their device, so they may not even be aware of the different functionality. So let's go over now and have a look at how we can implement these different layout strategies in code. So I'm over in Xamarin Studio and I've got a sample application called XF Orientation, which we'll use to talk through the different layout techniques. And I've put this up on GitHub, so you should feel free to look at it a little bit later on and dig into the implementation. I'll put a link to the code at the end of the lightning lecture if you want to go and download it. So I won't be going through all the code, really just the relevant bits. Now, the application itself just shows a list of different movie quotes, and when you select one of the quotes, it'll go to a detail page and show that quote. I've included a picker list on the main page, so you can choose the layout technique you'd like to use when viewing the quote, and you'll find that each of these pages looks basically the same when in portrait, but it uses a different layout in landscape orientation. And to keep things relatively simple, I've created different pages for fluid layout, extended layouts, and complementary layouts. So let's go and run the application and have a quick look at it first. Okay, so what we can see is up the top here, we have a picker, which lets you choose one of the different layout techniques. And down below that, we have a list of movie quotes. So if I have fluid layout selected and choose one of the quotes, you can see that it navigates to a page that shows the quote and the character. And if I go and rotate that device to landscape, you can see I get basically the same layout, but just resized to take full width of the page. So that's our fluid layout. Next, if I go back and I select extended layout, okay, and then choose one of the quotes, you can see again it navigates to a page that shows the quote, and it looks exactly the same as for the fluid layout. But if I rotate the device to landscape, you can see now I get some extended information. So in this case here, I get a movie poster. Okay, so if I go back again, and this time I'm going to select the complementary layout. Okay, and again, select a movie. In portrait mode, it looks the same as the other two. If I rotate to landscape, it shows an entirely different layout. Okay, so this time it shows information about the movie. Okay, and if I rotate back, you can see it just shows the quote. So let's go over now and have a look at how we implement each of these. First of all, our data itself is just coming from some simple hard-coded values. Here in our movie quote file, we have a basic class called movie quote, which is just our model for a quote, and we have a static class called movie quote generator, which provides some data to our movie quotes property. Now, if we go over to our main page and open up the main page.xaml, the layout of this page is really just a grid with a couple of rows. In the top row, we have a picker, which allows us to select our different layout types. And below that, in our second row here, we've got our list of quotes, okay, which is coming from our movie quotes. If we go and have a look at the code behind for this, when the user actually goes and selects one of the quotes from the list, we have our list on item tapped here. You'll see based on the different layout types, or the layout type that's selected, it's going to choose one of three main pages. So either the fluid layout page, the extended layout page, or the complementary layout page. And then it goes and navigates to that particular page. So let's go and dig into those a little bit. First of all though, let's go and have a look at our base content page. The base content page is the base type for all of these different pages. And in here, I'm using the onSize allocated method we talked about earlier to determine orientation changes. All we're doing here, basically on our onSize allocated, is looking at our width and our height. And based on that, we call our virtual method on orientation change to tell it the new orientation. And each of our derived pages can use that to go and handle the layout. So let's go and have a look at the fluid layout page now. And what you'll notice here is that there's nothing really special going on here at all. The layout for the page is all within a grid, but there's no special layout logic for portrait or landscape. We just rely on the fact that a grid has a horizontal and a vertical option for set to fill. So it's going to basically fill the screen. And in terms of rows, we have the top row, which has a height of star, which means it'll fill the available space, and then a second row with auto, and this is where our character name goes. If we look at the code behind for the fluid layout page, there's nothing really magical happening here either. Okay, so as you can see, fluid layouts are actually really easy to implement. What about our extended layout page? This is quite similar to the layout of our fluid page. We have our content contained within a grid, but you'll see that we have two columns specified here. The first one, which is going to contain the same as what we saw in our fluid layout, but the second column contains an image for a movie poster. And you'll notice that that image has the name of extended content. And what we're going to do is we're going to show or hide that based on our orientation. So if we go and have a look at the code behind, you can see here we're doing that in our onOrientationChanged override, which we're getting from our base content page. And all we're doing here is we're toggling the isVisible property based on our new orientation value. Of course, we could do this via data binding as well, but for the sake of illustration, I'm just doing it in code here. So again, it's quite a simple technique to implement. The more interesting layout is the complementary layout page. If we go and have a look at the XAML for this, you can see it's actually empty. And the reason for this becomes apparent when we have a look at our code behind. What we're actually doing in here is, based on our orientation changed, we're actually swapping out the content. So if we're in portrait orientation, we go and we make a call to get portrait view. And in this method, what we're doing is we're just checking to see if we already have a portrait content view instantiated. If not, we go and instantiate it. But then basically we return our portrait content, and then we're going to set that as the content here. And the only thing special about portrait content is that it's a content view as opposed to a page. So we can see that here. We do something a little bit more interesting in our landscape view though. In our get landscape view, what we actually have is two different landscape layouts, one for tablet and one for phones. So basically we just check our device.idiom to see the form factor and then return the appropriate landscape layout content. Okay, so we can see here if we're on tablet, we return a tablet landscape content, otherwise we return landscape content. So that can be a pretty awesome technique for having a single code base, but supporting different layouts for phones and tablets. So we should just have a quick look at this running. So first of all, let's run it on our phone simulator again and see what we get for that. Okay, so we'll turn that into landscape mode, and that's our layout on a phone in landscape. Let's run this on an iPad now. And here we can see we have a completely different layout on a tablet for our landscape mode. So we have the movie information over here, and we've got a web view over here showing us more content. Another interesting thing from iOS 9 is that now that we can have split screen views, things become a little bit more complicated. Okay, so if we have a piece of content obscuring this, it's all cool. If this actually becomes split here, we need to adjust our layout, because even though we're in landscape, our actual screen real estate here is still very much like portrait. And what's cool is our on-size allocated actually deals with that. So we can see here we've got a constrained space, and we're showing it in our portrait sort of layout. If I take this back over here, you can see it will swap back to its landscape mode. So that's just a quick illustration of how we can do those three different layout styles. And again, feel free to dig through the code and have a bit of a look at how that's implemented. But what we'll do now is we'll just go back over the slides and we'll talk about how we can lock our orientation. The last topic we'll have a look at is how you can lock orientation for your application. So some applications just aren't suited to working in both landscape and portrait orientations, and in those circumstances, you might want to lock the orientation. By default, Xamarin.Forms solutions enable device orientation changes on all three of the platforms, but we can actually go and change that, and the way we lock orientation is going to be different depending on each of our platforms. On iOS, this can be achieved by setting values in the info.plist file in your project. On Android, you can specify the screen orientation declaratively with your activity attribute, or you can specify it programmatically via the requested orientation property, which you can set in the onCreate method of your main activity. And for Windows Phone, in the mainpage.xaml.cs file, you can change the supported page orientation enumeration member to portrait or landscape. Another consideration in regards to orientation is that people use phones and tablets in very different ways. Just in terms of numbers, taken from the mobile overview report produced by Censure Mobile, their statistics showed that when using phones, a vast majority of people use their devices in portrait mode. But the story is very different when we look at tablets, where the split between portrait and landscape is roughly equal. So a common strategy is to lock the orientation on phone form factors and allow rotation when on tablet. We can do that fairly easily based on our device.idiom that's provided by Xamarin.Forms. So let's go and have a look at how we can lock our orientation on our applications, including based on whether it's running on a tablet or a phone. First, let's see how to lock orientation on an iPhone. This is actually pretty straightforward. All you need to do is open up the info.plist file under your solution. You'll see here there's some options in here for iPhone deployment, which allows you to select the allowed device orientations. So if we want to lock this to only run in portrait on an iPhone, we can deselect everything apart from their portrait orientation. Down below, you'll see some other settings for iPad deployment. And again, we can select which orientations we support in the iPad. And for our case, we'll allow all orientations. So now we have an application that locks the orientation to portrait on iPhones, but allows any orientation on iPads. So let's test this out. First of all, we'll try on an iPhone. So if we try and rotate our device now, we can see that we're locked to portrait orientation, just like we wanted. Now let's swap over to an iPad device and test it out there. Okay, if we rotate the device now, the application should respond. And it does. So really that's all there is to locking orientation on iOS. Now let's have a look at Android. In Android, you can specify the orientation in the onCreate method of the main activity. Let's go and have a look at that. And in here in our onCreate, we can add a bit of code which checks the device.idiom. And if it's a phone, then we can do something like lock the orientation to portrait. We can do that through the requested orientation property. So let's try this out on a phone and make sure that it actually gets locked. All right, and we can see that looks exactly how we want it. Now let's just make sure our orientation still works on tablet. So we'll load up a Nexus 10. And we can see the orientation still works on a tablet. So all looking good. Finally, let's look at how we do this on Windows Phone. With Windows Phone, you can specify the orientation in the main page.xaml.cs. In our constructor, we can set the supported orientations. And again, we can also do a check here to test the device.idiom if we wanted to lock it for a particular form factor. And it's very similar to Android, and that's all you really need to do. So now we've seen how to lock the orientation on iOS, Android, and Windows Phone. Obviously, whether your application locks its orientation is going to be very application specific, but you now have the tools to detect orientation, adjust your layouts, and also lock your orientation where appropriate. So that's it for this lightning lecture. Thanks so much for watching, and hopefully you've seen some techniques that you can use in your Xamarin.Forms applications to take advantage of orientation. You'll find the code for this lightning lecture available on GitHub at the link on this slide. And as always, if you've got any questions, please feel free to shoot me an email. And I hope to see you on some upcoming Xamarin University classes.